Okay, so today we have 12.5 again, and we cover average value. So last time we were finding the area underneath the curve. Today we're going to do the same exact thing, except we are now going to find the average value of an area underneath the curve using the given formula, of course. So this says that the average value of a function over some interval AB, if f is a continuous function on the interval AB, and capital F is any antiderivative of f, then we have the formula 1 over b minus a times the integral from a to b of f of x dx will equal 1 over b minus a of f of x evaluated from b to a to b, and everything we've done already. So the only thing new is we are adding in this 1 over b minus a. So we're doing evaluation theorem that we did last time. We were just applying the new part of the formula, 1 over b minus a, which will find the average value. Okay. Here are those integral formulas again, in case we need them. There is one new one, and it is going to be this guy. I think we'll need it for an application problem. So this says the integral of e to the ax dx, the antiderivative will be 1 over a times e to the ax plus c. So we'll use that formula when we need it. Okay, so let's go ahead and try this out. Find the average value of the given functions on the given interval and graph the function and its average value over the indicated interval. Okay, so we're going to find the average value and graph it as well. Okay, so number one, this says g of x equals 2x plus 7 on the interval 0 to 5. So this interval is your a, b. So by the formula, we are going to get 1 over b minus a, 5 minus 0, times the integral from 0 to 5 of the function 2x plus 7 dx. So that's how we set up to find the average value. Okay. Okay, and now all we have to do is clean up a bit, and we are ready for the antiderivative. So what we're going to do next is write 1 over 5 times, and here we go for the antiderivative. The antiderivative of 2x is going to be 2 times x squared over 2 plus the antiderivative of 7 is 7x. And we will be evaluating these from 0 to 5. Okay. And again, just clean up a little bit. That 1/5 will stay here, and it's going to be 1/5 times x squared plus 7x evaluated from 0 to 5. Okay. And now you can evaluate the inside. So we can rewrite this as 1/5 times 5 squared plus 7 times 5 minus, you'll have 0 squared plus 7 times 0. And then almost there, we get 1/5 times 25 plus 35, which will give me 1/5 times, I think that's 60, right? So we're going to get 12. So this is the average value of this function on the interval 0 to 5. Okay. And of course, is there a better way? Yeah, we get to use Desmos. What's up?
I was about to ask that question.
So for Desmos, all we're going to type in is, of course, clean that fraction up. And you get to have 1/5 times the integral of 0 to 5 times 2x plus 7 dx. This is exactly what we're going to type in. Don't worry, I know how to save you guys some time. Okay. So we're going to type in that. I'm going to do 1/5 times the integral from 0 to 5 of 2x plus 7, close that, and then dx. And there we go. We get 12. So that's all we have to type in. So again, for showing your work, at least get to this step. And then you can put the answer that Desmos has in there. So at least get to this step. Okay. And now we want to graph the function. So that's our next thing, is graphing this function on that interval 0 to 5. Okay. So what's great about this is, again, we'll use Desmos. So I'll just say graph. Then here we are. Here's 0, 1, 2, 3, 4, 5. And I'm going to type in this function in Desmos. The function is 2x plus 7. And I'm going to use that table feature. And we're going to type in those x values from 0 to 5. 0, 1, 2, 3, 4, 5. So this means at 0, I'm at 7, 1, I'm at 9. And it doesn't have to be perfect, it's just a sketch. So let's go ahead and just start this at, let's say, it's going by 2s. So we'll just say that this is 7, 9, 11, 13, 15, 17. So here's 7, here's 17. And then when I graph this, 0, 7, 1, 9, and up, 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 up. And here is our function. And then all we have left to do is graph the average value. So the average value was 12. So average value was 12, but we're going to write it as an actual equation. So we're going to say average value, y equals 12. So 12, that's 7, 9, 11. So 7, 9, 11, 13. So 12 is going to be right here. So this line represents the average value at 12. And there we go. That's what we're doing today. So again, last time we found the area underneath a curve, underneath a given function on an interval. Today, we're still doing that, but we're finding the average value of that area. So for this function, the average value of the area would be 12. Okay, any questions on that? And Desmos, again, makes life pretty easy. So let's try it again. 2. F of x equals x minus 3x squared on the interval -1 to 2. So our setup, we're going to have So here is A, there's B. So you'll have 1 over 2 minus A, which is 1, -1. So 2 minus times the integral from -1 to 2 of x minus 3x squared dx. Now clean it up and you get 1 over 2 minus 1, which becomes plus plus. So you'll get 1/3. And then we are ready for the antiderivative. So I'll put the brackets there. And the antiderivative of x is going to be, x squared over 2 minus 3 times the antiderivative of x squared, which is x cubed over 3. And we evaluate this from -1 to 2. Okay. And now one more cleanup, and I give 1/3 times, and I'm just going to rewrite this as 1/2 x squared minus, your 3's will cancel, x cubed evaluated from -1 to 2. And now we're ready for Desmos. So for Desmos, I'm going to type in 1/3, so 1 divide 3, and then the integral from -1 to 2 of parentheses x minus 3x squared, and close that with respect to x. And there we go. We get -2.5. There's our average value. Okay. And now we graph it. So say here's -1, 0, 1, and 2. And then let me type this function in, the regular one, x minus 3x squared. I think that's it. Use my graphing table, and we're going to choose the values it's telling us. -1 to 2. -1, whoops, 0, 1, and 2. Okay. This means I'm at -4, 0, -2, and -10. So we'll just make this 2, 4, 6, 8, 10. There's -10, and there's -2. And when I graph this, I'll have -1, -4, 0, 0, 1, -2, and then 2, -10. So here's our graph. And then all we have to do again is graph the average value, which is going to be represented by the line y equals -2.5. So here's -2, there's 2, so -2.5 somewhere around here. So that is y equals -2, oops, 0.5. Okay, there we go. Any questions on that first page? Now that Desmos has made life easy, right?
Yes, sir.
Okay, let's keep going then. All right, 3. F of x equals the cube root of x on 1 to 8. So let's go ahead and set up again. So here's A, there's B. So we get 1 over b minus a on the integral 1 to 8 of the cube root of x, which we're going to rewrite as x to the 1/3 dx. Okay. And then clean this up. We get 1 over 7. And once again, we're ready for the antiderivative. X to the 1/3 gets power rule. So you'll get x to the 1/3 plus 1 over 1/3 plus 1, evaluated from 1 to 8. And then clean up some more. 1/7 times x to the 4/3 over 4/3, evaluated from 1 to 8. And last cleanup before we use Desmos, we get 1/7 times 3x to the 4/3 over 4, and evaluate from 1 to 8. Okay, Desmos time. Let's go ahead and type in that original or that antiderivative. So we're going to go back up here. It's going to be 1 over 7 times the integral from 1 to 8 of x to the 1/3 dx. There we go. We'll just do this to 2 decimal places, and I will get 1.61. There we go. And now to graph it. We're doing this from 1 to 8. So here's 1, and then 2, 3, 4, 5, 6, 7, 8. Let's go ahead and put this in the actual graph. X to the 1/3. Use my table and type in those values. 1, 2, 3, 4, 5, 6, 7, 8. There we go. Graph it. I get 1, 1. Oh, I need to make these. So the highest we go is 2. Cool. So there's 1. We'll make that 2. And then I have 1, 1. And then I'm just going to do 8, 2. That'll just make it neat because we'll look something like that. Okay, and then our average value is y equals 1.61. So we'll just put that somewhere right in the middle. There it is. Y equals 1.61. All right, not bad. All good? Okay. All right, 4. Given the demand function, find the average price in dollars over the demand interval 500 to 900 for the function 3000 over x. Okay, cool. All right, so let's go ahead and set up our integral. So here's a, there's b. So we'll get 1 over 900 minus 500 times the integral from 500 to 900 of the function 3000 over x dx. Okay. And I think I remember this problem being specific. I think in my math lab, it wants you to actually give them the integral before finding the antiderivative. So let's go ahead and clean up before we find any antiderivative yet. So this will be 1 over 400 times the integral from 500 to 900 of 3000 over x dx. And then, yeah, this problem was definitely weird. It wants you to multiply the 1 over 400 back in. So we'll get the integral from 500 to 900 of 3000 over 400x, because again, you multiply it straight across, dx, and we'll go ahead and reduce 3000 over 400, which is 7.5. So now we get the integral from 900 to 500 of 7.5 over x dx. So this answer is for one part of my math lab question, which means now let's go ahead and find that antiderivative.
So quick question, what did we just find right there?
All we did here was set up the integral. That's it.
Okay.
So yeah, I believe in the question it tells you set up the integral, and then after you set it up, it's going to ask you for the answer.
So all the previous questions we had before were already set up integrals?
Exactly, but these were already set up, but this one, for some reason, wants you to multiply that 1 over 400 back in. Because for you see, for these ones, we didn't multiply that 1/7 back in, right?
Mm-hmm.
Yeah, so that one, for these ones, it's honestly, on your homework, all it's going to say is what's the area. I don't think it makes you graph them. I think maybe one problem does. But like, let's say you got number 3 on your homework, it's just going to say what's the area. If you type a 1.61 and hit enter, you move on.
Nice.
So yeah. So you know my math lab, it's weird. Okay. So now let's go ahead and take that 7.5 out. So we'll get 7.5 times the integral from 500 to 900 of 1 over x dx. And remember, the antiderivative for 1 over x is the natural log. So this is going to become 7.5 times the natural log of the absolute value of x evaluated from 500 to 900. And now we can use Desmos. We'll type in that green one I circled right above. Okay. So here we'll do integral. Here's 500 to 900 of 7.5 over x dx. There we go. And to 2 decimal places, we get 4.41. And this is the average price in dollars over this demand interval. So let's just put a label on it. Average price in dollars. Okay, cool. All right, number 5. Given the price supply function, S of x equals 8 times e to the 0.5x minus 1, find the average price in dollars over the supply interval 40 to 50. Okay. So for this problem, we're going to need that special integral formula that was on the first page. I'll just rewrite it here. So we said the integral of e to the ax dx is 1 over a e to the ax plus c. Okay, so that's the formula we're going to use here. So let's go ahead and get set up now. So 8 times e to the 0.05. Okay. Over 40 to 50. So here's what we have. So we're going to get 1 over 50 minus 40 times the integral from 40 to 50 of 8 times e to the 0.05x minus 1 dx. Okay, so a little bit of cleaning up to do. And we know that this will give us 1 over 10 times the integral from 40 to 50 of 8 times e to the 0.05x minus 1 dx. And what we're going to do here is take the 8 out. We're going to factor that 8 out. So this is going to give us 8 over 10 times the integral from 40 to 50 of e to the 0.05x minus 1 dx. Okay, so this means that we were all set for the antiderivative. And let's get started. 8 over 10, that reduces to 4/5. And now, using that special formula, the antiderivative of e to the 0.05 is going to be 1 over 0.05 times e to the same exact thing. So that's using that special formula minus the antiderivative of 1, which is just x. And we evaluate from 40 to 50. And now Desmos can step in. So we're going to have, I'm going to type in the second line. So this is the one I'm typing in. 1 over 10 times the integral from 40 to 50 of 8 times e raised to the 0.05x minus 1. Close that. Did I close that? Yeah, I did. Dx. And there we go. We get 68.69, or we can even say 70. Why not? 68.70. And this would be the average price in dollars again. I can't even write. Ugh. Okay, cool. Sweet. Okay, everybody good with that one?
Mm-hmm.
All right then. Last one. So the total cost in dollars of printing X dictionaries is C of X equals 20,000 plus 10X. Find the average cost per unit of 1,000 dictionaries are produced. There's the average cost formula. B, find the average value of the cost function over the interval 0 to 1,000 and interpret the results. Okay, so first thing we're going to do is find the average cost, which is something we learned in 1324. Remember, the average cost formula is C bar of X equals C of X over X. So all we have to do here is find the cost function and put it all over X. And then I think it wants us to plug in 1,000. So that's what we're going to do here. So for A, C bar of X is going to be the cost function, which is 20,000 plus 10X, and you put it all over X. That's the average cost function. Now we're going to plug in 1,000. And I got Desmos up. So lucky us. Plug in 1,000, I get 20,000 plus 10 times 1,000 all over 1,000. And we get $30. So $30 is the average cost per unit. So I think it's the average cost per dictionary. Come on, computer, let me write. I'll just say book. Okay. Now B says find the average value of the cost function over the interval 0 to 1,000. So for this one, we're going to set up a integral. So for B, and we're finding the average value. So this means that you're going to get 1 over 1,000 minus 0 times the integral from 0 to 1,000 of just the cost function, 20,000 plus 10x dx. There we go. Okay, and now clean up, of course. So we get 1 over 1,000, and we are ready to find the antiderivative. The antiderivative of 20,000 is just 20,000x. The antiderivative of 10x is going to be 10 times x squared over 2. And we evaluate from 0 to 1,000. Okay, one last cleanup. It's 1 over 1,000 times 20,000x plus 5x squared from 0 to 1,000. And here we go, Desmos. We'll type in 1 over 1,000, and then the integral from 0 to 1,000 of 20,000 plus 10x with respect to x. There we go. And we get $25,000. And this is the average value. So this is the average value of the cost function. So to interpret our results, well, it cost us $30,000. I mean, not 30,000. It cost us $30 to make each dictionary. But then if we make 1,000 dictionaries, the average value of making 1,000 dictionaries is going to be $25,000. So that's how we interpret this. So C, we know it's $30 per dictionary, or like I said, I'll just say book. And then it's 25,000 for producing 1,000 dictionaries. And that's it. That's average value. Where again, Desmos is our savior. Okay, so we are done, I believe. Let me see. Yep. Okay.